Hello everybody and welcome to the final video in this project on natural language processing in Python. We've covered the basics, and so now we can actually do text classification where we will deploy a machine learning algorithm, a support vector machine to be specific, to classify movie reviews as either positive or negative. So we're going to have a data set of a bunch of different documents where those documents are movie reviews, and we want to have the computer learn whether or not it is a positive review or a negative review, just based off the words that are contained therein. So we'll look at how we are going to take tokenized words and then use them as features that we can feed into our machine learning algorithm. We're also going to look at how to wrap the scikit-learn package with NLTK and use classifiers from scikit-learn in Python through NLTK. So let's go ahead and get started. Previously, we've covered tokenizing, stemming, part-of-speech tagging, chunking and chinking, and then named entity recognition. So we're going to use some of these basics, this foundation that we've built to do this text classification. But for now, let's go ahead and just import a couple libraries that we need. I'm going to import NLTK again, just so for readability's sake. And then from the NLTK corpus, we're going to import the movie reviews. Oh, and we need an underscore there. So movie reviews. So that's the set of documents that we're going to be using. And remember, if you don't have the movie reviews installed already, you can go nltk.download. And this is going to pull up an NLTK GUI that you'll be able to download those from. So this is thinking a little bit. It's still processing here as noted by this asterisk. Hopefully these will import correctly. There we go. We see the one, so it worked. And we're going to be using the random to set a random seed so that we can improve our reproducibility a little bit. And again, I'll just run this really quick so that you can see. If you were following along in the other project videos, as I hope you were, then you already understand how the NLTK downloader works. But if not, here you go. You can go to the corpora, all the different documents, and in here you can find the movie reviews right here, actually, and get that downloaded and installed. It should be relatively quick. It's just a zip file. All right, so now that we have that, let's compile a list of our documents. So we're going to build a list of documents. So to do that, we are going to use the movie reviews that we just imported, and we want them as a list. So we have movie reviews.words, file ID, category. So we're going to use an inline function here because these are a bunch of different reviews. So what we can do is we can do a for category in movie reviews.categories. So these two categories are actually going to be positive and negative here. They're split into those different categories. And then for file ID in movie reviews.file IDs for each category. So there we go. This is going to build that list of documents, both positive and negative reviews. And once we have this imported, we can go ahead and explore this a little bit. But let's keep building this. We want to shuffle the documents. That way we don't have all of the positive reviews and negative reviews in order. That could skew our results. So let's use the random.shuffle documents. Okay, there's that. Let's actually start printing out a few things so we can learn more about this data set that we're building. So let's go ahead and print out the total number of documents. I'm just going to use a length documents, so it's going to tell me how long that list is. Let's also print out the first review so we can see what these look like. .format, documents. All right, here we go. We'll do the first one here. Okay, that should be good. All right, and now what we want to do is we want to build a list of all the words contained in, because we want to use these words as features. So we need an entire list of all the words, not just split into these different documents. So we're going to do that in a very similar way as we did the documents. We're going to use a for loop. So for W in movie reviews.words, parentheses here, I'm going to do all words.append W, which is our word here, and then we'll do a lower to make sure it's a lowercase. All right, that's awesome. This is a list of all the words, and then we'll take that list, all words, and we can do a convenient NLTK frequency distribution of all those words. So this is going to sort them by most common to least common, and it's doing that using this frequency distribution function built into the NLTK library. So awesome. Let's take a look at some of those. So we'll print out most common words. Let's get these. All words dot most common. Let's take 15 here. That's good. And then let's print. How about the word happy? And we're going to print out how many times happy comes up. So we'll format all words, and we can use the key index here of happy. So this is going to tell us how many times happy comes up in all words. All right, so if we have everything correct, we can go ahead and run this, Shift Enter. And so this is going to build a list of the documents, shuffle them, and then generate this combined list of all the words in these movie reviews. So this is going to take a little bit because there are, well, I'll just tell you, there's 2,000 documents in this data set, so it's got to run through each and every one of those. And it also needs to append a list of all the words. It's got to sort them, and it's also doing these print functions as well. So here we go, though. It actually didn't take that long. I've spelled documents wrong up here. That's going to bug me a little bit. That's okay. So number of documents, 2,000. Here's the first review. It shows that America remains ambivalent over the nature of its political system. Probably true. But these are all tokenized into words. And it's got the entire review here. So most common words, we have most common is actually punctuation, and then we get into the. We have another period, a. So that makes sense, you know. Commas and periods and the words a, the, and obviously going to come up a lot of the time. So here these are, and actually the word happy shows up 215 times in these reviews. So that's a good thing. It's good to be happy. So there you have it. So this is the data set that we're going to be using. Let's take a look at converting these words over to features. So let's just out of curiosity's sake, let's print the length of all words. Let's see how many we have here. So we have 39,000 words, 768. So a lot of input. But we don't need all of these. We aren't going to use, 39,000 different features to train our machine learning algorithm on. So what we're actually going to do is use only some of the most common ones. So let's use the 4,000 most common words as features. So word features equal list all words dot keys, and let's go ahead and take the first 4,000 of these. So this is an interesting way to build features. These may not be the most informative features, so we could have ways to improve this in the future. But for now, when we're just looking at a basic introduction to text classification, we're not going to bother with processing our data set too extensively yet. So we'll take these features and we'll assume that they are a good way to go. All right, so there's that. Let's run Shift Enter on this. That runs pretty quick. So now we have our word features. We have 4,000 features. And then let's build a find features function that will determine which of the 4,000 word features are contained in a review. So here we go. For each document, we want this function to be able to sort through it and determine which of the features are in the review. So we'll do a find features, and it's going to take an input of document, which is going to be a review in this case. So words, let's take set document, and the documents already have the words tokenized, so we don't have to do that. So here are our words. Let's build a features, and we're going to start a dictionary. We're using brackets here, so this is going to be a blank dictionary. You know, in Python, you have a list. The brackets, the curly brackets, are going to give you a dictionary. All right, and now we can loop through these. So we'll do for w in word features w equals w in words. So if that word is contained in the list of words in our document, we're going to start building this dictionary of it, where the key is going to be a w, or the word, and the value is going to be a true or false type scenario. All right, let's return these features. And then let's use an example. So let's use an example from a negative review. So this is what the features is going to look like. Features, we can just call this function now, find features, and we'll do movie reviews. So we want to pass it just one document, .words. So I already know the file name. This is coming from the negative category, and then CV000_29416.text. So this is just one of the reviews. And then let's actually print these out. So for key value in features.items, if value equals true, print the key. Oh, we need a colon here. Print the key. All right. So let's go ahead and run this. And that was really quick. We've already got the output here. So in this review, we have the following features. We see that we get like the periods, because of course the period was one of the most common words. But we also have a lot of other descriptive words in here. Perhaps problem could give away that it's a negative review. Horror, perhaps confusing. This could be a dead giveaway that this should be a negative review. But here are our features. This entire list of features is a binary true or false for each feature as to whether or not the word is contained in that document. So this is what we're going to be feeding into our machine learning algorithm, or our support vector machine in this case. But again, this is just for the one particular document. So maybe we could actually print these out. Let's just print the features dictionary that we just generated so we can see what that looks like. So this is going to take a little bit longer, but you see, so for the majority of these words, and this isn't in order from most common to least. Dictionary does not store order in Python, so these are randomly shuffled. You have for each word a true or false as to whether or not it's contained. So since we have 4,000 words here, and only maybe 20 or so were found in the document, most of these are false. But again, there are going to be a couple trues mixed in. So let's go ahead and clear this output. We know what that looks like. Let's go ahead and do this for all the documents. For all the documents. You know, we had our one example text. Now let's build all of our inputs. So feature sets, we'll call these feature sets. And we're going to do another inline for loop. So we'll have find features of review for comma category for review category in documents. So for both the positive and negative reviews, we're going to find the features for each review in our documents, which was the list of all the documents that we generated up above here. right here. So we built that list of documents, and now we're going to build this feature set off of them. All right, so let's go ahead and run this, make sure it works correctly. So this is going to be a pretty big variable here, this feature sets, and it did run. So we see that number there. So now let's we're going to start importing sklearn, and we're going to use the model selection to import the train test split function, which we've used in the past to build a training and testing data set. So let's go ahead and do that. So we can split the feature sets into training and testing data sets using sklearn. So we are going to, from sklearn, import the model selection, which again we've used in the past. Let's define a seed for reproducibility. So we'll say seed equals 1. And actually, perhaps when we shuffled the documents up here before, we should have set our seed before that, but that's okay. We'll just do it now. All right, so seed equals 1. And now let's actually split the data into training and testing data sets. So training, testing equals model selection dot train test. Train test split feature sets. And let's define test size. Test size is 0.25. Since we have a lot of data, we can have a big validation data set. And then random state equals seed. So there we go. If you've noticed, you might be kind of confused by this because in the past, when we've used this train test split function, we've actually had 4 outputs. We've had the X training, the Y training, and then the X testing and the Y testing. And this is actually going to be because of the way that we have to pass these training and testing data sets through the NLTK to the sklearn. We don't need to pull off the class or the positive or negative tag from these training and testing data sets yet. And so since we don't have an X and a Y here, we only have feature sets. This is just going to split this into training and testing. So we'll look a little bit later about why that's different. So let's go ahead and run this, and it's already done. So just for fun, let's print the training length and then print the length testing. If everything went well, we should get 1500 in the training. I have a spelling error here. There we go. So 1500 in the training, 500 in the testing. This makes sense. We had a test size of 25%. So this is good. We have 500 documents, 500 reviews to test our algorithm on, and we have 1500 to train it on. So now let's look at how we use sklearn algorithms in NLTK. So we're going to need to import a couple things. So from nltk.classify.scikit-learn, let's import the sklearn classifier. And then from sklearn.svm, let's import that support vector classifier, which we've come to know and love in previous projects. Let's go ahead and run this so everything works. We already have these installed. That's good. All right, so now we have to start an instance of our sklearn classifier. So model is going to equal the sklearn classifier. And inside of this, we are going to use our standard sklearn class, which is the SVC. And let's define a kernel here. I'm going to use a linear kernel. We could test out some others if we wanted, but linear is a good place to start. So we have to, each time we use these scikit-learn classifiers with NLTK, we have to wrap it in this sklearn classifier class. So we have to use this first, and then this is what we are going to be passing our information to later, our training and testing data sets. So shift enter, that ran, good, we're good to go. Let's move on. So we can train the model on the training data. Step number 1. So our model, our SVC, wrapped in the sklearn classifier, we can just do simple dot train, training, pass it all of the training data. No need to separate the class here. And we'll shift enter, and this will think for a little bit. We're fitting that support vector classifier to this data, trying to find that optimal separating hyperplane, which is going to divide these different documents into either positive reviews or negative reviews. And there we go. So let's go ahead. This is all run, but remember, information from our training doesn't necessarily tell us that much. So let's go ahead and test on the testing data set. So let's see how well we are able to generalize to documents that we haven't seen before. So let's do accuracy equals nltk.classify.accuracy. We'll pass it the model, which is fully trained, and then we'll pass it the testing data set. And let's go ahead and print that out. So we'll print the SVC accuracy. We'll use the dot format to substitute in a variable into our string here, accuracy, end parentheses. All right, so let's see how we did. So going through the testing data set, we are thinking, testing, classifying documents, still thinking, and here we go. So 63% accuracy, certainly not the most accurate classifier that we have seen in any of our projects to date, but that's okay because we are just getting started. There are tons of different ways that we can improve this result, but for now, we're just trying to build that foundation for natural language processing. So we don't have to go into those details too much yet, but we will in a future project, so that's okay. So we can learn how to improve these results later, that's fine. In this project, we built a foundation for natural language processing in Python. We covered tokenizing, stemming, part-of-speech tagging, chunking, named entity recognition, and then finally we just did text classification. So some of those ways that we'll look at improving this result in future projects will be at combining multiple classification algorithms. So we don't have to use just a support vector machine. We can combine this with perhaps a naive Bayes classifier or other classifiers to produce better results. Furthermore, we'll move on to more difficult challenges, such as sentiment analysis. Is the overall review positive or negative is a pretty easy sentiment to classify, and we'll look at some more difficult scenarios in the future. But thanks for following along. You have built your foundation. This is actually the end of the project. We covered all the basics, the tokenizing. We learned a little bit about some vocabulary in natural language processing, and we built all the way up into doing a simple text classification of either a positive or negative movie review based off a feature set that we built from all of these documents. So again, using the most common words as features. These aren't going to be the most descriptive since all the documents have probably a comma and a period. And so we'll look at a better way to build features later. But for now, the big takeaway here is probably how to import this sklearn classifier and use it to deploy sklearn algorithms through this NLTK package. All right, thanks very much for listening. I hope you learned a lot from this project.